Okay, so we remember from yesterday, hopefully, that parallelograms, the only requirement, the definition of parallelogram is that it's a quadrilateral with two pairs of opposite sides that are parallel. That's all you need to fulfill the definition. Okay, so I'm going to rejot that down. Parallelograms. By the way, there is a symbol for parallelogram if you don't want to write that word over and over and over again. I'm going to switch to a darker marker. I don't think that one's dark enough. Let's try brown. So the symbol for parallelogram just looks like this. So if you want to just draw that symbol instead of, actually, let me do it a little bit better. Instead of writing the word, save yourself a bunch of time. Okay? So parallelograms are quadrilaterals, two pairs of opposite sides parallel. That's my definition, okay? Now, yesterday we actually saw a little sneak preview into one of the properties of parallelograms. If you go ahead and try and draw yourself a parallelogram. So draw yourself a shape where you really do, as best you can, make the opposite sides parallel. Go ahead, just sketch any old shape, but try and make the two sides parallel to each other and the top and bottom parallel to each other. If you correctly make a shape where that is true, where you have top and bottom parallel to each other, let's say. So if I have these two yellow ones and I really try and make them parallel to each other, that looks pretty good. And then I come in and I gotta make it longer to match up with these. There we go. So there's one side of my parallelogram. Oh, let me zoom out a little bit more. There we go. And so if I just go ahead and draw in that other side so that it's, as best I can, parallel with the first side, turns out that the only way to make that happen, where you have these two parallel and these two parallel to each other, what's going to end up happening automatically is that the opposite sides not only are parallel, but they're also equal to each other. So it's easy to see on my shapes because they're the same color. So the two sides that are yellow are not only parallel to each other, but they're also the same exact length. Same thing is going on with the green sides. They are parallel to each other and they're equal in length. So even as I sort of mush this around, notice the two greens are still parallel. The two yellows are still parallel. And of course, they're still the same length, right? So it doesn't really matter how I sort of contort this shape, right? It's always going to stay true. The two greens are always parallel and the two yellows are always parallel, no matter how you shift this. That's so cool. So turns out that for any parallelogram that you draw, any one, it does not matter. It doesn't even matter if it's a rectangle. It doesn't matter. You will always have both pairs of opposite sides not only parallel, but also equal in length. So in other words, it's impossible for you to make a parallelogram where, let's say, instead of this green piece, I tried a different color, so a different length. It would be impossible. It wouldn't be a parallelogram anymore. So let me try. Let's see if let's take this pink one, right? So if I tried, okay, well, I can make the pink one parallel to the green one, but it's never going to connect. The only way it's going to connect is if it is the exact same length. So that is a really interesting property of parallelograms, that not only are both opposite sides parallel, but they are also congruent. Always. So every parallelogram has this property where the opposite sides are parallel and congruent. Wow. All right. So let's go ahead, and it's both pairs, mind you, right? It's the tops and the sides. So I'm going to we're going to kind of make a list here. Properties of parallelograms. So the first one that we just discussed was that opposite sides are congruent. All right, so think about any parallelogram that you can create. You will notice that this is always going to be true. Your opposite sides will always be congruent, and of course parallel, otherwise it wouldn't have been a parallelogram. All right, now the next fun fact that we're going to talk about has to do with their angles. Okay, we already know that all the angles add up to be 360 because it's a type of quadrilateral, so we already know that that's true, but that's true for every quadrilateral. I want to know what's true for specifically the parallelogram. Okay, so here's how this kind of works out. Let's take a look at my parallelogram here. So remember that the top and bottom are parallel to each other, and so are the sides. But let's just focus on the top and bottom for a minute. So they're parallel. You know what? I'm gonna trace this shape. That didn't work out great. Hold on. There we go. That's a little bit better. Let me just get rid of that smudge that I made. All right, so there's my parallelogram sort of traced. What I'm going to do, though, remember that the top and bottom are parallel to each other, right? Okay, cool. What I'm going to do is I'm actually just going to extend these lines a little bit. So I'm just going to make this longer and darker so we can see a little bit better. Same thing down here. And I'll even do the same thing with the sides. So look at what I have. This is sort of a throwback to a couple chapters ago. You have a pair of parallel lines being cut by a transversal now. What do you know about angles 1 and 2? Do you remember how to name them? So if we were doing like corresponding, vertical, same side interior, same side exterior, alternate interior, alternate exterior, can anybody refresh our memory what angles 1 and 2 would be to each other? Anybody remember? Some of you are really good at naming those. Have we forgotten already? Oh no. Oh dear.
Wait, what was the question?
I want to know what angles 1 and 2 are to each other. So like corresponding, vertical, alternate interior, alternate exterior, blah, blah, blah. What are angles 1 and 2?
Same side interior.
Yes. And can you or anyone refresh our memory? If they are same side interiors and the lines are parallel, what does that mean about the, how do I say this without giving you the answer? If I were to add angles 1 and 2 together, what are they going to add up to be?
180.
Yes. Same side interiors are going to be supplementary. So what that means is that these two angles, 1 and 2, are going to be supplementary to each other. Okay, now, though, watch this. All right, angles 1 and 2 are supplementary. That's great. Don't forget, though, that this is a parallelogram. So not only are these two parallel, but the sides, these sides are also going to be parallel. So this one and this one are parallel. So that means the same thing is going to happen with angles 2, and if I put an angle 3 over here. Angles 2 and 3 must also now be supplementary because they're another pair of same side interiors. Here's my lines and here's their transversal. So these two are also supplementary. And you can play the same game and do it all the way around. So if I had an angle 4, these two are going to be supplementary. And 1 and 4 would be supplementary. This is true for every single parallelogram. If you take any two angles, one right after another, they have to be supplementary to each other. Do you see that? They have to be. 1 and 4 have to add up to be 180. 4 and 3 have to add up to be 180. 3 and 2, and 2 and 1. All the way around. Okay, so let's go ahead and add this to our list, but now I drew all over my list. Let's see, I'll do this. All right, so we had opposite sides are congruent, and now we're going to add into it any pair of consecutive angles, so that's one angle right after another, is supplementary. And there's sort of an offshoot of this that we're going to find out in just a second. Let's try a problem now, and then we'll see if we can add to this list. I should have done this on another page. Oh, well. All right, so let's take a parallelogram. So I'm going to mark it with all the markings to know for sure that it's a parallelogram. Okay, got it. So watch what you can do with this now. I only have to give you one angle, and you can find all of the others. That's it. That's all I have to give you is just one. So watch this. If I tell you that this one here is 80, let's say, we just found out that all the way around they're going to be supplementary. So if this one is 80, what's this one over here have to be?
80.
Careful. They have to be supplementary. Right? So it's not going to be 80. It's going to be, what's supplementary mean? Anybody got an answer for me? What must this angle right here be? Knowing that these two angles are going to be supplementary, and that one's 80, that means this one's got to be
100?
Yes, supplementary just means adds to 180, right? So if that's 80, that means this one has to be 100. But now you can keep going, right? You can keep going all the way around. These two have to be supplementary. So if this is 100, what does that mean this one is?
That would be 80.
Yes, this one's got to be 80. And then these two would have to be supplementary. So if that one's 80, this one has got to be 100. Which makes sense because these two are supposed to be supplementary also, and they are. 80 and 100 really add up to be 180. Now hold on. Check this out. Look at these two. Those are both 100s, and these are both 80s. Do you think that's going to happen every time? Maybe, maybe not. Let's try another one. What if I did something like, I don't know, let's put it on its side, first of all. We'll do something like this. Okay, and again, this will be a parallelogram, so I'm going to mark those sides parallel. I'm going to mark these sides parallel, so we know for sure this thing really is a parallelogram. Okay, got it. So let's say this first angle down here, this little small one, let's say it's 20. If that one's 20, what does this one have to be?
160?
Yes, thank you. 160, because these two have to add up to be 180. So this one's got to be a 160. Okay, and then I do the same thing. These two in a row, if that's 160, this one has got to be 20. Yes, thank you. I got it in the chat. And then if that's 20, that means this one's got to be 160. Hey, hold the phone. Check that out again. Oh, did my camera just freeze? I think so. Give me 1 second. I'll just restart. Stupid thing. Okay, there we go. So we were just talking about how, yes, look, it appears as though it happened again. The angles across from each other are the same. And that is always going to happen. So now, not only are any pair of angles in one after another are going to be supplementary, but the ones across from each other are going to be equal. So let's add that. Any pair of opposite angles are congruent. So that's going to save you a ton of time if you are. So remember the problems from the homework last night where I gave you 3 of the angles and you had to find the 4th. Now, if you know it's a parallelogram, you know the answer to that really fast. Because it's just got to be the same as whoever's across from it. But you got to be careful because you got to make sure that they're parallelograms. If it's not a parallelogram, that does not hold true. Okay, and there is one fun fact left to learn about parallelograms. And I'm wondering if you guys can figure out what it is without me just coming right out and telling you. And I'll give you a hint. It has to do with the diagonals. What do you suppose might be true about the diagonals of a parallelogram? So a very common guess is that the diagonals are equal to each other. Yeah, so that can be true, but it's not always true, because watch this. If I squish this, look at the diagonals here, right? So one diagonal is going to go from here to here, and that's pretty short. That's a pretty short diagonal. And then the other one, oh, I'm so sorry. My other diagonal is going to go all the way from here, oops, all the way down there. So that one's really long. So they are not always going to be equal to each other. It can happen where they are, but that's not going to be true every time. So I'm looking for something that is true every single time. Yeah, usually one's short and one's long, but they can be equal. But there is something that's really neat that happens with these two. So it's kind of hard to guess it, but it turns out that where the diagonals meet each other, they divide each other in half perfectly. So in other words, they're not the same length, but this piece right here will be the same length as this piece right here. And this piece here will be the same length as this piece right here. Every single time, no matter what my parallelogram looks like. So I'll do it again with sort of a different looking parallelogram. Let's do this one that's kind of a bit more wider. Okay, so I'll do my best to sort of hold this in place so it doesn't move. So I'm going to draw my two diagonals. There's one, and then the other one. There we go. So if I were to actually whip out a ruler and measure that meeting point is the midpoint of each of these. So those two are the exact same length. And these two are the exact same length. That's so cool. So for any parallelogram, it doesn't matter what it looks like. It could be a rhombus. It could be a square. It could be a rectangle. It could be just any old regular parallelogram like I had here, right? This is just any old parallelogram. And it doesn't matter how you make it look. If you draw in both diagonals, they will always cut each other in half perfectly. It's so neat. So that's our last fun fact about the parallelograms. So I'm going to try and squeeze it in here just so that I have the full list in one spot. So my apologies that this is not exactly how I didn't give myself nearly enough space. All right, so the last fun fact. The diagonals of every parallelogram. Do you remember that fancy vocab word for cuts in half perfectly? Starts with a B.
Bisect?
Yes, bisect. The diagonals of every parallelogram bisect each other. That's so cool. Any parallelogram you could possibly draw. So if you have a ruler and you'll really take the time to draw yourself an accurate parallelogram, so you really do have both pairs of opposite sides parallel, if you go ahead and draw in those two diagonals and measure them, they really will bisect each other. How cool. All right. So, yeah, I think that's everything that I wanted to cover on this. So I'm going to jump to the homework real quick and just make sure that there's nothing that I left out. It's going to be on CUDA. So let me just make that live and then I'll do a few out. But I think I hit everything that I wanted to. Desktop. When I do, when I teach this D block, I'll do a better job with the notes. So I'll actually post their notes instead, since these are, I mean, they're all right, but I can do better. So if you are looking later and you're like, hey, these notes don't match what I have, that'll be why, because I'll do theirs better. Okay, so let me share this screen with you and we'll do a couple of these together. If you feel confident and you're ready and you want to try it on your own, that's fine. It should be, did it already post? I don't know. I don't think so. Did it? No, I think it just opened. All right, hold on. Let me post it for you. You guys are B block. All right, it should definitely be there now. This is homework 18 we're looking at, 8-2 parallelograms. Let me share this. I'll do just a few. Okay, so you're going to start off with some pretty easy ones. So remember, the very first property that we talked about is that opposite sides are going to be equal to each other. So that side's 10, that side's 10. And you know it's a parallelogram because they told you up here in the directions. They said that they're parallelograms, so you know you're not just guessing. They told you, so if that's 10, that's 10. So that should be easy enough. That's easy peasy, easy peasy. And now, all right, now we're going to start getting to the angles. So remember that any two angles in a row as you go around, it doesn't matter if you're going clockwise or counterclockwise, right? So just as you go around, so T and U have to be supplementary. U and R would be supplementary. R and S would be supplementary. Any two in a row, okay? So that means, of course, angle T has got to be 100. Same thing. So you just keep going. These two in a row have to be 74, and whatever this is have to add up to be 180. So if you have two angles in a row, they're supplementary. If you have two angles like this, these are across from each other. So what did we learn about angles that are across from each other in parallelograms? They are the same, exactly. So this one, you get to jump right to the fact that this is 62. You could figure out 62 and this one are supplementary, and then this one and this one. But if you know our third bullet that we listed, they're just got to be the same. So just be careful. Pay attention whether you have ones that are consecutive, one right after another, or if you have ones that are directly across from each other. That's going to make a difference. And then you're eventually going to hit these ones that deal with the diagonals. Okay, so let's see. Let me just grab my stylus here. There it is. FD is 32.4 in this. So what does that mean? Let's come in here. And FD is this whole thing. So if that whole thing is 32.4, and we just learned that the diagonals, right, where they meet, what happens? They cut each other in half. So this little piece FC is going to equal this little piece over here, CD. And that's what I'm trying to find is CD. So in this particular one, all I have to do is take 32.4 and cut it in half, because that will get me CD, which is what I'm looking for. So half of 32.4 is just 16.2, right? So be careful. You got to watch whatever information they're giving you, and just remember the fact that the diagonals are going to cut each other in half. So let's try the next one. So be careful now. This one's giving you LE, which is only this part. So this part is 19.2. Oops, I went a little too far. LE right there is 19.2. 19.2. There we go. And I'm trying to find LJ, so be careful. LJ is the whole thing. So what's my answer? Thank you. Yes, it is B, 38.4, right? Because in this case, I'd have to double it if I wanted the whole thing. So just be very mindful of what part they're asking for and what part they gave you. All right. But as long as you know that these two pieces will be the same and these two pieces will be the same, you should be golden on these. All right. I'll do one more. Why not? LP is 6 and they wanted LN. So if LP is 6, that means PN is 6. So that means LN, the whole thing, is obviously going to be 12. And that's it. All right. And I think that's it. So there's only 18 of them for you guys to do. Does anybody have any questions right now? No? Okay. So feel free to go ahead and start this if you haven't already.
we do when we're finished?
Like, I don't know, any of the work that you're missing, I guess.
Miss Sabia, I'm done.
Oh, right. I'm trying. Oh, I'm trying to find it on my end, but I'm clicking all over the place and I don't see it. Am I in the wrong? Oh, there it is. I just want to see how people are doing. Haley, you are all set. I will see you tomorrow.
Bye, have a great day.
Thanks, you too. I've got Haley is all set. Olivia, you're all set. Kira, Mark, Juliana, Elizabeth. You guys are good. If you have old stuff to do, you should do it. Not yet started. I've got Vinny, Lyric, Chase, I know is absent. Dylan, Megan, Caden, James went MIA. Alex and Ethan have not started yet.